In today's lesson, we are going to look at what we refer to as the 5-number data summary. When we started these lessons, in our previous lessons, we said that statisticians obtained a feel for the data they were about to analyze in two ways. Mukarangarira how we defined statistics, tichiti we are going to start with the collection of data, toenda ku collation of data, then we are going to go to the presentation of data by use of visual aids, tozoenda ku analysis of data. So those are the keywords which we used to define statistics. Saka we have been discussing the collection of data, the collation of data, and we were actually more inclined towards understanding the presentation of data presentation. Panapa zvakuchiitika tava a different way from data presentation which statisticians use to understand data. We have now dealt with the first way, that of constructing a visual aid. Saka maybe if we want to write it as a note, tinenge taakuti statisticians, including you, a student of statistics, use two main ways to understand data. What are the two main ways? Number one, they use visual aids, kana kuti visual displays. And this will be part of what? Data presentation. Saka when data is presented, tichishandisa ma diagrams. So far we have looked at a stem and leaf diagram, we have looked at a pie chart, we have also looked at a bar chart or bar graph. We are soon to look at an histogram and other visual aids which are in our syllabus. Saka zvatiri kutaura, visual aids and displays, they are used to understand, kana chiti understand our source reader iri kuti to have a few of. Saka to have a few of, something like that. So what is going to be number 2? Now we move on to the second way by computing a few key numbers which summarize the data. So the second way which we use, which statisticians use to understand data, is what we refer to as the 5-number data summary. So this 5-number data summary is the subject of our lesson today. Our aim now is to reduce a large batch of data to just a few numbers which we can grasp simultaneously and thus help us to understand the important features of the data set as a whole. Saka mnenge muine a data set, let us say in a 500 observations, takuchitaura real world data, and maybe you've collected data pavana vechikoro and vana vacho they are almost 2000. Yet you just need to summarize the data so that you have a feel, you understand, munova ne idea yekuti data rakamira sei. Saka in order for us to summarize data, we need 5 numbers. What are going to be these 5 numbers? Saka the 5-number data summary consists of the first number is the minimum value. Correct, in your data set, murukutsvaga the smallest data value, the smallest number in data set. Then the second number we look at, this one is either called the first quartile which we are just going to write as Q1. The third number is called the median, which we can also represent as Q2. The fourth number is called the third quartile, which can also be Q3. Then lastly, tinechi the maximum value, kureva number wombesa in that particular data set. So these are the 5 numbers which are used to summarize data. Now takuda kuchita go through the different methods which we use to find the minimum value, the maximum value. Saka minimum value and maximum value, we can find them simply through observation, but first quartile, median ne third quartile ndo yatinofanirwa kuwana by use of other methods. But method yatoda kushandisa panapa in this lesson toda kushandisa method yerank. Method yerank inowanzo kushanda kana tapiwa a data set nema values akawanda, say in 30 observations kana kuti ne 50 observations. Tikada kutsvaga the median, first, third quartile tichishandisa manual methods, it's going to take us a long time. Saka we are going to combine what we learned by stem and leaf diagram. Then we are going to learn about a rank. Then after we have done so, it is going to become easier kutsvaga the 5 number data summary. But we are also going to introduce lessons where we learn about this 5 number data summary not using the rank, kana kuti tichishandisa manual methods which we also refer to as from first principle. Okay, so we start our journey learning about what we call rank. What is this rank? It is useful now to introduce the concept of rank. In a numerical data set of size n, sorted from smallest to largest, the smallest number is said to have rank 1. Saka chekutanga, we should do what? It's a numerical data set. Saka we sort the numerical data set Remember, it is of size n. It is of size n. From the smallest value to the largest value. Like this. And what do we refer to this? This is called arranging in ascending order. Let us have a very small example of let us just say ngatiti data set redu rakamira so 1 4 8 9 10, something like this. Saka we have to rearrange. Saka pakurearrange tinotanga tanyora the smallest number, which in our case it's 1, then tonyorachi in ascending order. So it was actually in ascending order. Saka zvatiri kutaura panapa kuti in a situation where this numerical data set of size n, saka n ndo makuriro akaita data set, when we have arranged it from smallest to largest, after rearranging, the smallest number is said to have rank 1. Saka kana tichiti rank, hama dzangu, tiri kungoreva the position of a data value kana kuti a number in a sorted data set. In a sorted data set. Saka kana tichiti rank, tiri kungoti kana taita rearrange kana tasota our dataset, then namba yekutanga ndo inenge iri first rank, inotevera iri second, ino iri third, iyo fourth, iyo fifth. But the key word kana kuti what we should do before we start naming ranks, tinofanirwa kunge taita se taita sort our data set starting from the smallest number to the largest number. Mapabata. Saka the second smallest ndio inenge iri rank 2, third smallest inenge iri rank 3. Maybe let us write this so that it makes a sense. Saka panapa tiri kuti the second smallest number is rank 2, andika toramba tichienda rank 3, rank 4 and so forth. But you should also know kuti the largest number is rank n. Nemakaitati it is rank n because kumsoro kuno kutataura kuti the size of our dataset is n. Saka n iri kungoreva the number of data values atinawo in a dataset. Like for example, tinogona kuva ne 20 marks, and from a class 20 marks, that's our dataset. Saka n winge iri equal to 20. We dealt with examples where n is equal to 30, n is equal to 20, especially patanga tichi construct ama stem plots. Saka that is what is happening there. Saka tanyora izvi, what are we going to deduce from this? We call the smallest number x1, and it saka we call the smallest number yatati ine rank 1 iyo x1, like that. Then we are also going to call the second smallest number x2. Saka muri kuonere kuti ka1 kanaka neka2 aka zviri kurepresenta chi rank. Ndozvandoda kuti muone. Saka because of that, it should then be easier kuti the largest number, we call the largest number what do we call the largest number? Xn, like this. Saka x1 iyi ndio inenge iri chi, tinogona kuiti x1 kana kuti tinogona kuiti x min, kureva the minimum value because ndio the smallest in the data set. Then xn inoi tinogona kuiti xn kana kuti xg max because ndio the largest number we have in the data set. Saka kana takuda uchinyora this statement more loosely kana kuti more generally, tinenge takungoti we use xr for the number with rank r. Saka we use tatositsanangura xr and for a number with rank r. And that's a very important point. Okay. Saka the cumulative count column of a stem and leaf plot makes it easy to find the observation with any given rank. So kuti tiwane maranks, we are going to be using a cumulative column yatichawedzera pa stem and leaf plot. Saka pese patachiconstructa ma stem and leaf plots edu tanga tisingawedzeri a count and a cumulative count. But I'm going to show you how we do that when we are going to be doing the example. So maybe let us write it as a note preemptively. Kuti we use muzorangara this note, the cumulative count column of a stem plot to find the rank of a number. That is what we use. Very important point. Please musoirangarira. Okay, saka ngatichidhila nerank tichitarisa kuti zviri kufamba sei. We use x r plus half to denote the number halfway between the numbers with rank r and rank r plus 1. Saka write this note kuti we use x r plus half. This is to denote the number halfway between the numbers with rank r and rank r plus 1. Saka zviringotaurwa panapa ngatiti we have a data set like this. Saka taarrange our data set. So this is a sorted data set. Sorted data set. Kureva kuti tiri kutangira pa the minimum value tichigumira pa maximum value. Saka zvatiri kudzidza apo ndezvekuti we know kuti rank panapa r anenge ari equal to 1. We know kuti rank for a maximum value r anenge ari equal to n. Saka ngatiti we just from nowhere kana kuti we just select two numbers. And saka ta selecta number iri panapa where the rank is r, then we select another number where the rank is r plus 1. Saka tikada kuziva kuti saka what is going to be the rank pakati pe these two data values, these two numbers. The rank is going to be r plus half. Ndozviri kungotaurwa. Saka kana tiine two mavalues ari mudata set atinoziva, these values tichiziva marank awo, we know kuti the rank inenge iri pakati it's x r plus half. Saka kana takuda kuzinyora in mathematical terms tinenge takuti x of r plus half like that iri equal to x r andika, which is the value with the rank r plus x of r plus 1 value with rank r plus 1. This is over 2. And you should know this formula, but we are going to simplify it a lot, so much so that you are going to see how it is used. Saka this formula, it's more like showing you where our formulas which we are going to be producing very soon are coming from. So that is what is happening. Saka patakudhila ne the rank of a number, hatichangodhili ne the actual value itself. Like tatsanangura kuti rank ingori number inotudza the position of a data value inside a data set. We say that x of r plus half is the number with rank r plus half, like we have shown there. Such numbers are called half ranks. And saka this is just now preemptive. Saka this number is called what? A half rank. Something you should just know. Saka what then is going to be the median in light of this information? Saka median inenge imbori chii pamarengi papapa. Saka median ichanetsa here. Why ndichiti median haifangokunetsa? Median haifangokunetsa nekuti tine a sorted data set like this. Iri kutangira pa minimum value ichigumira pa maximum value. We know kuti for the first number the minimum value r anenge ari equal to 1, for the last number r anenge ari equal to n, like that. Saka inonzi median, we know kuti it's inumber iri pakati panapa. Ndochi ndo median. Okay, we define the median of a bunch of n numbers as the number which has the rank n plus 1 over 2. Saka our first point, the median has the rank. What is the rank? N plus 1 over 2. Iri ndo rank ye median. Mapabata, that is the rank of the median. Okay, let me show you what we mean. Tikadzoka panapa, I am sure kuti tese tinoatesta kuti pa this data set our median is going to be 8. Why tichiti our median is going to be 8? Because kuside kunoko kune 2, kuside uku kune 2, saka 8 ndo number iri pakati. And we should also acknowledge kuti n panapa ngari odd, kureva kuti we have an odd number of observations. Okay, saka kana chida kutsvaga median, satinogona kubva tati median rank taudza kuti the rank of the median iri equal to chi n plus 1 over 2. N inorevei? N inoreva the number of numbers, data values in a data set. Saka panapa number yedu ichi 1 2 3 4 5. Saka it's going to be 5 plus 1 over 2. Kureva kuti rank ye median ichi is 3. Saka murikuona kuti this 3 ndiyo inenge iri rank ye median. Saka median yacho inenge iri chi? Inenge iri number iri under 3, which is 8. Saka we can actually find what the median is tichishandisa the knowledge of the rank of a median. I'm going to show you other ways of doing it which are simpler, but for this lesson we want to work with the rank. Nekuti kana mukapiwa a stem plot, this is the way of going about it. Of course you can do it manually from first principles, but you'll be wasting your time and also increasing the chance of errors. So I've shown you how the rank is going to work. Saka we use xm to denote the median. The median is denoted as xm. That is how we denote the median. If n is an odd number, then the rank of the median will be a whole number, and the median will be the middle number in the data set. So zvatoda nyora izvi zvinonyanya kuoneka kana takuita examples, but let me just explain it. We write the notes, then I will explain it in simple terms so that you understand what we mean. Saka panapa tiri kuti kana n ari odd, and when n is odd, then the rank of the median will be a whole number. Saka chekutanga rank of median is a whole number. What else? Chimwe chiripo panapa ndechekuti the median will be the middle number. The median is the middle number. Saka kana data redu for example rakadai 3 6 8 10 12 like this, murikuona. Saka mukatarisa panapa muchaona kutanga kuti n iri equal to chi 1 2 3 4 5 iri equal to 5, which is an odd number. Saka kana muchida kutsvaga the median, tikuda number iri pakati, you can see kuti 8 ndiyo number iri pakati, because this is already arranged in ascending order. Saka mufanira kutanga maarrange izvi zvakatoarrangewa. Saka muona kuti 8 ndiyo number iri pakati. Saka kuri kuti tanga tichida rank of median, tanga tichizoti rank iri equal to n plus 1 over 2 which is 5 plus 1 over 2, which is 3. Mukona kuti it's a whole number. And saka this ODU is going to change when n is even. Saka what happens when n is even? The rank will be a half rank. The rank is a half rank. Ndochekutanga kureva kuti it's not a whole number. Ndozviringoreva, don't be confused by this term. Chimwe chinoitika ndechekuti the median is the average of two middle numbers. So pamakaita statistics dzeku O level, I'm sure you were taught this. Of two middle numbers. An example would be ngatingotorai the same data set but tongobvisa 12. Saka if it is 3, 6, 8, 10. And saka panapa you can see kuti n iri equal to 4, which is even. Saka hatikwanisi kungoya pano tototora a number. Hapana number iri pakati apa, because tikada kutora 8 for example, kunoku kuna 10, uku kuna 3 na 6. Makoma akakosha anokuratidza kusiyana kwazvo. Saka muri kuona kuti hazviiti kuti tore 8. Saka zvatinoita manje, tinotora manumber 2 ari pakati, which is 6 na 8. Saka median inenge iri equal to manumber 2 ari pakati, 6 na 8. So it's 6 plus 8 over 2 ndo average. Why that over 2? Because tatora 2 numbers. Saka we need the average of the two middle numbers. Saka panapa inge iri 2 into 6 into 3 into 4 into 8 into 4, 4, 5, 6, 7. Saka 7 ndo inenge iri median. Saka mugona kuti pakati pa 6 na 8 pana 7 asipo. Ndi anoya ari median. Ndo zviri kungotsanangurwa hapo. Saka kana maitsvaga median ku level, you were using this. I'll bet you did not have the technical terminology and jargon which we are using now. Okay, Saka, we have shown you how it is done. Let us now go to the lower quartile. The lower quartile. Saka lower quartile, which is Q1, Inofamba say the lower quartile is defined to be the number with rank L. Saka tinoti the lower quartile yanchanyora as Q1 is a number with rank L. And it tova tazoti where L rank yacho iri equal to, but sisai iri equal to a mari muka bracket kakakosha nichakudzai zvakanoreva plus 1 over 2. Saka panapa tiri kuti L is equal to bracketed m plus 1 over 2. That is what we are saying. It's not difficult. It's not difficult. Andikuya kuyanga iri like kumsoro kupatati tsvaga the rank of a median. Anditanga tichiti n plus 1 over 2. Panapa takungo replace n na bracketed m plus 1 over 2. Because takatotsanangura kuti lower quartile kana kuti first quartile median ye the first half of the data. And we explained this. It is the median of the first half of the data. Okay. So what about m yakamirira chi? Saka ka bracketed m aka, what does it represents? Saka m akamirira chi? M ari kureva the rank. Saka m is the rank of the median. Ndokuti m is the rank of the median. Okay, saka rank of median tatinowanikwa sei? rangarirai vana vanehanda tati rank iyo inowanikwa sei its n plus 1 over 2. Sa munogona kuzoti manotsi enyu that is m is equal to n plus 1 over 2 like that. Okay, but remember ndataura kuti notation yekuisa mabrackets maboxed brackets yakakosha. So the notation of m means that if m is something and a half, then we drop the half. Saka kudai so means if m is something and a half, we drop the half. Ndikasesa example panapa pana zvandinenge ndaita. Example, kana tacalculate m tikaona kuti m are equal to 2.4, boxed m inongoreva kuti tinotora 2. Saka hazvina basa panapa kuti for example m are equal to 2.8, still boxed m tichangotora 2. Saka hatisi kuraunda, tiri kungoignore that decimal part, tongotora whole number part chete. Ndo zvinoreva notation yekuti boxed m. Muri kupabata? That is very, very important. The alternative to doing this is having to define quarter ranks. Okay, so we are not going to do that. Let us now look at the upper quartile. Saka upper quartile yakamira sei? The upper quartile is rank. Saka totanga the rank of the upper quartile kana kuti the rank of Q3 yakamira sei rank yacho? U is equal to n minus L plus 1. That is what the rank is. U is equal to n minus L plus 1. The lower and upper quartiles are denoted as XL and XU. Saka this upper quartile, it's what? XU. Then kunoku, the lower quartile, yanga irichi XL. L is equal to U is equal to. It's almost obvious. Okay. The extremes, the smallest and largest values in a data set, have ranks 1 and n. Of course, we can tatombo zinyora, and we agreed earlier to call them x1 and xn respectively. These 5 numbers provide a useful summary of the batch of data called, with complete lack of imagination, the 5 number summary. Saka manje takuchida kungo summarize what we refer to as the 5 number summary. The 5 number summary. Saka the 5 number summary yakamira sei? Kana makuinyora inenge yakadai. Nesa bracket, then munoziva kuti your first value ndi x1. Your second value, which is the lower quartile kana kuti first quartile, inenge iri xl. Number yenyu yepakati, which is the median, the xm. Then mofonga mova maziva kuti number yenyu inenge iri upper quartile the xu. Mozopedzisira neyo maximum value, which is xn. This is it. Saka tikazoya pano tikati in terms of rank, in terms of rank. Saka toda ngonyora ari ma rank formulas. You are going to appreciate kuti x1 rank yacho inenge iri 1. Ko lower quartile rank yacho inenge imbori chi? For the lower quartile, rank yacho inenge iri bracket ra-m, remember, plus 1 over 2. For the median, rank inenge iri n plus 1 over 2. For the upper quartile, remember, rank inenge iri n minus l plus 1. Then lastly, for the upper quartile, rank inenge ngori n. Saka eu iyi yanyorwa panapa ndiyo eu yatinge tawana apa. Okay, saka tinogona kudai muri kurangarira ka kuti panapa tanga tichiti l uyu ndiye e, uyu ndiye e anozoshanda pano handiti. Then remember kuti panapa uyu ndi m, then uyu ndiani ndi u. So please don't forget that. Okay, today's lesson was a little complicated, I give you that. It was a little in depth. I'm sure to most of us the issue of a rank is very new, and you are going to see the importance of using ranks. I encourage you to keep on repeating this lesson until my formula have second nature to you, makuma understander. They make life really easy. It might be a little over the syllabus which we should be doing, which is ZIMSEC or Cambridge A-level statistics, but using ranks really makes your life easier. Mukapiwa a dataset in 30 observations. You really wish you were able to use ranks rather than kutanga maarange 30 numbers. Mozotanga kutsvaga kuti where is the median, where is the first quartile, the third quartile. That makes life a little hard. If this lesson has benefited you in any imaginable way, may you please consider liking, subscribing, and sharing. If you feel you want to attend our private class learning statistics at A-level, WhatsApp us please on this number, and we'll see how best we can assist each other. Thank you and take care.